Hey, 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 everybody. Hello, students. Here we are in the close-up view of the laboratory to complete our lab activity now on page 28. So I will be collecting the data for you, and you are to complete the activity in your books. So let's get started. At the top of the page, the problem states, how can density be used to determine if an object will float in water? What does that actually mean? Well, if you recall in the last activity, you calculated the density of water. So you now know the density of water is, what is the density of water, everybody? Not just one, but 1 gram per milliliter. 1 gram per milliliter. Very good. But the answer is 1. 1 gram per milliliter. Now, what this question is asking you here is this. If you find the density of another object or two, and in this case, you know that we're going to be determining the density of object A and object B. And looking at those densities, will examining the density be able to tell you whether an object will float or sink in water? What do you think? Don't say it out loud, but take a moment to write a hypothesis. What do you think? Do you think that knowing the density of an object will help you know whether it's going to sink or float in water? Do you think it's not going to help you? What do you think? Take a moment and write that down. All right, now we're going to follow these procedures and I will perform them for you so that you can write down your observations. The next step says, in the procedures we are, obtain materials and set them up. Well, I've got that all done for you. Step 2, determine the mass of object A by using the balance. Remember, we use a balance to determine the mass of an object. Well, here is object A. Object A is a wood block. And I'm going to turn on our digital balance here. And I'm going to read, actually, I'm going to turn it around so I can see it a little bit better since you can't really see it anyway. So I'm going to read the mass. Oh, that's easy. The mass of this object is 5 grams. 5 grams is the mass of object A. Now, it says record your data. So go down into the observation section where it says mass in grams of object A. Write down 5 grams. Next step. Determine the volume of object A by using the ruler. Using the ruler. Well, here is object A. And here is the ruler, and it wants us to determine the volume of this object. Now, thankfully, this object has irregular dimensions. What would you call this in math class? A rectangular prism, perhaps? But here we have this 3-dimensional object. It's got 3 dimensions: length, width, and height. Is there anybody, raise your hand if you know how to determine the volume of a regularly shaped object like this that has a length, width, and height? If you said volume is equal to length times width times height, you're right. So let's do that. Let's measure the length first, using our ruler. And here we go. It is 10 centimeters. Now, that's not the volume. That's just the length. The length is 10 centimeters. The width is 1 centimeter, and the height is 1 centimeter. So the volume of this block is 10 times 1 times 1. Write down what you think is the volume of block A, where it says object A, volume in cubic centimeters. It's 10 times 1 times 1. Next step. Calculate the density of object A and show your work and express the density in grams per cubic centimeter. Now, it says there density down below, grams per cubic centimeter. That's the space where you're going to write it. If you can't figure it out quickly, don't figure it out yet. Let's go on to object B, and then I'll give you time to do all the calculations. Step 5. Determine the mass of object B. Object B. Here is object B. It's a little metal object. So I'm going to place it onto our digital balance after I zero it. And the mass of object B is 50 grams. 50 grams. That is the mass of object B. Next, determine the volume of object B by using the graduate. How are we going to do that? Well, we're going to use the displacement method. Remember Archimedes from Monday? So we're going to put a certain volume of water into our graduate. I'm going to put 50 milliliters. There we go. 50 milliliters of water into our graduate. Then I'm going to place the object into the graduate. And as we do that, what do you think is going to happen to the volume of water in the graduate? Do you think it's going to stay the same, go down, or go up? Nice. It's going to go up. How much is it going to go up? Well, it's going to go up the exact volume of our object. But now let's be careful. We don't want to just drop this object in because some water might splash out and we'll lose that volume. But rather, you're going to take the graduate and by the way, remember what the volume is right now. It's 50. Tilt the graduate and lower the object in slowly. And check that out. The volume went up. It did go up. And it went up 10 milliliters. Now, hold on a second. If it went up 10 milliliters, but that object is a solid block, how should we be expressing the volume for object B? What units should we use? Volume, 50 cubic centimeters is right. Very good. Now, it continues to say, calculate the density of object B and show your work. So you can write that down. You can show your work later on. And let's see here. Bleep, 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 ba-doop, boop, ba-doop, boop, 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 boop. Boop, 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 boop. The next step says, place both objects in water and see if they float or sink. Well, I think you can see what happened to object B in the water here. Here's object A, and I have a container of water here that I'm going to place it into, and notice what happens. It is floating in the water. So object A floats, object B sinks. Here are your observations. I would like you to record all of the information and pay particular attention to the densities of these two objects and see if there is a relationship between their densities, whether they float or sink, and what the density of water actually is. We'll talk about that when you're all done. So I'm done collecting your data, so I'm going to say bye-bye.